Hello everyone, welcome to ExamRat. My name is Shatabdi, I'm a second year medical student. Today we'll be continuing with our third session of gravitation where we'll discuss some questions on it. Okay, so our first question here is, how does the force of gravitation between two objects change when the distance between them is reduced to half? Okay, so first let's just write down our formula that we know and let's call it as the initial force of gravity. So it is G m1 m2 by d square. Okay, so we have to find the changed gravitational force, right? Like what happens after the distance between them is reduced to half. Okay, so we can write it as final force G m1 m2 by d by 2 whole square reduced to half. So now to find relation between any two quantities or the change that has occurred, we just divide the final minus the we divide the final by the initial. Okay, तो ये करने से क्या होगा, Gm1 m2 by d square. We know that in division when we multiply उसका inverse हो जाता है when we multiply the denominator, so it will be like d square by 4. I've squared both d and 2 here, so by G m1 m2. इससे we start off everything, तो यहाँ पे we will, what will we get? So yeah, okay, no, यहाँ पे we had done final minus initial, sorry, so यहाँ पे basically, or we can just like, since I wrote the initial wala pehle, I'll just so I can just write it here as fi minus f final. तो हाँ, यहाँ पे क्या होगा, initial force divided by the final force, we will get as 1 by 4, or we can write it as the final force is basically 4 times the initial force. So from here we get it proven like that we had talked about the fact that when the distance between two objects starts decreasing, the force of gravity increases because now they are coming close to each other. And why is that? Because force of gravity is inversely proportional to the square of their distance, right? So that is why when we reduce the distance between them to half, the new gravitational change became 4 times the initial one. So the next question here is similar to the first question only. What happens to the force between two objects when the mass of one object is doubled? Okay, so let's just first again write the initial G m1 m2 by d square. Now here in the first part, if mass of one of them is doubled, we can write it as G m1 into 2 m2 by d square. तो यहाँ पे भी फिर से डिवाइड करने से क्या होगा, now we're dividing the f1 divided by the initial one. So यहाँ पे again let's write G m1 to m2 by d square into d square by G m1 m2, right? So we strike off all the values except 2 रह जाएगा. So from here we basically get that the new changed gravitational force is twice the initial force. तो फिर मास डबल करने से, बिकॉज ये डायरेक्टली प्रोपोर्शनल है ना, तो मास डबल करने से फोर्स ऑफ ग्रेविटी भी डबल हो जाएगा. ओके, सो नाउ द सेकंड पार्ट इज द डिस्टेंस बिटवीन द ऑब्जेक्ट्स इज डबल. पिछले क्वेश्चन में था रिड्यूस टू हाफ, यहाँ पे डबल्ड. सो f2 we can write as that Gm1 m2 by 2d whole square, which will be Gm1 m2 by 4d square. So again when we divide f2 by f initial, all these values are going to be struck off, and what will remain is that, if I just divide it by fi, basically what will remain is 1 by 4, right? Or f2 equals to 1/4 of Fi. Matlab, if we increase the distance between two objects, then the gravitational force will decrease because F is inversely proportional to d square. Okay. Our third question, mass of both the objects are doubled. Again, very simple. In the first case, we had done mass of one of the object is doubled here. So for the third one, we'll just again multiply this whole thing by 2 because we are just doubling this mass, no? तो यहाँ पे क्या होगा? Into 2. So into 2 or F3 basically if we write F3 is basically 4Fi because we are doubling the masses of both the objects. Okay. In this question, it's also very simple. We know that anything that weighs, let's say W on Earth, it will weigh W by 6 on Moon, right? On Moon. Okay. So what are we gonna write here? That we know that the weight in newtons of if 10 kg is the mass. Now it is the mass, right? We know mass everywhere is constant, and if we multiply it by acceleration due to gravity, we get the weight. So weight on Earth, if weight on Earth is basically 10 into 9.8 Newton, which is 98 Newton. So its weight on Moon will be WE by 6, which is equals to 98 divided by 6, which we get around 16.34 Newton. Very simple. Okay. So this question is technically, if you take a look at it, you'll think that it is from the Newton, like the first chapter, right? And what was that? Motion in one direction. But since we in this chapter have discussed about acceleration due to gravity, its value, its formula, so I think in that way it is justified for it to be discussed here as well. Okay. So just 1 second. Yeah. So let's discuss the first question, the velocity with which it was thrown up. So we know that when the ball reaches up, as upar gaya, so for a moment its velocity will be 0, right? And then it will again start from 0 and it will gain a velocity. So for this case, that when it was thrown up, we can assume that the final velocity is 0. And u we have to find out. Also, the total time is 6 seconds here. Matlab, time of ascent equals to time of descent, which is equals to 6 by 2, 3 seconds, right? Okay. So how will we find out here if we have, we don't know u, we have got the time equals to 3 seconds and we know g equals to, let's take 10 meter per second square here, just for r, so that the answer comes in a whole number. So we can just use that formula, v minus u by t equals to a, or यहाँ पे it will be g rather, sorry. So since the ball is thrown up, we have to take the acceleration as minus. Just remember that because it's against the gravity, it's going up. So minus u equals to minus gt, both of them positive. So u equals to 10 into 3 seconds because we are just calculating the throwing up distance here, मतलब the throwing up velocity, the velocity which it was thrown up. तो सब ऊपर का ascent का we are considering here. So it is 30 meter per second. Okay. The maximum height it reaches, very simple, s equals to ut minus gt square by 2. यहाँ पे भी minus होगा. So s equals to, we can do it as 30 into 3, which is 90, minus 30 by 2, right? 10 into 3 by 2, तो यहाँ पे it is -90 -15, right? Okay, so it's gonna be basically okay, sorry, just okay. So the second part of the question is that the maximum height it reaches, we can easily calculate it by uh, v square minus u square by 2g, which is s. So now we know the final velocity is 0 because it reaches the topmost point. So s is basically equals to u square by 2g, which is 900 by 2 into 10, which is 45 meter, right? So it is technically minus 45 meter because it's against the gravity. But since distance we can't really say कि minus में होगा, so we'll just write 45 meter. So s equals to 45 meter. Now its position after 4 seconds. Now this is kind of a tricky one. So what basically we have to do here is that we know that जाने का 3 seconds लगता है and आने का भी 3 seconds लगता है. So we have to find its position after 4 seconds. मतलब 3 seconds का it went and then while coming back 1 second it has traveled. So this position basically we have to find out, right? So total का 4 seconds one. So first we'll just find out कि in that 1 second how much did it travel. Okay. So we know that the moment it is coming down, its initial velocity is 0. Like ascent ka final velocity becomes descent ka initial velocity, which is 0. And yeah, so ut minus sorry, यहाँ पे plus होगा because it's coming down, half gt square if we use, so this becomes 0. We know time here we'll have to take 1 second, right? So half into 10 into t square, which is 1, so 5 meter. So it traveled 5 meter in 1 second, and we know that the total distance, like the maximum height, was 45 meter. So what is its position? Its position, it's basically 45 minus 5, which is equals to 40 meter. Okay, so that is all. Now so this one will be 40 meter from the ground, its position. Now we come to the last question here. It is the volume of a 500 gram seal packet is this much. So will it float or sink? We know that for it to sink on water, its density has to be greater than 1 because we know water's density is 1 gram per centimeter cube, and this is for sinking. And for floating, D has to be less than 1. So let's find out the density of the seal packet. Density is 500 by 350, which will come to 0.7. Now since 0.7 is less than 1, the sealed packet will float. Okay. So now what will be the mass of the water displaced by this packet? This we have to find out by Archimedes' principle, right? So it had said that the amount of the water displaced by it will be equal to the volume that is immersed or partially immersed or floating on water, right? So for the sealed packet to remain completely afloat, it has to displace equal volume of water, right? Every second it has to give out or displace equal amount of water so that it keeps floating, right? Otherwise it will sink. So what we can say here is that the volume of water displaced is equal to the volume of the sealed packet, right? Packet, I'll just write in short form, which is equals to 350 centimeter cube. But the question is not finding the volume, the question is finding the mass of the water displaced. So if we have the volume here, we know the density of water is 1 gram per centimeter cube, right? This is rho. Rho is another way in which we can, or we can just write it as D, it's fine. Yeah, so we know, we know the density, we know the volume. So how will we find the mass? Mass displaced is equals to density of water into volume of the water displaced, which is equal to volume of the sealed packet, which is 350. Which this gives us 1 into 350 or 350 gram, right? So the mass of the water displaced by this packet is 350 gram. Okay, so that will be it for today. It was a very short discussion. I hope you guys understood it. If not, just go through our notes below. This whole PDF will be given to you in the group description. So thank you and keep watching.